Hello, my name is Igor and welcome to my tech farm. I have a filament dryer review again, and this is the Sunlu S2, a new filament dryer from Sunlu company, and I will do a review and comparison with the S1, the older version. First of all, I would like to thank to my patrons for supporting me, and every cent from them is spent for sensors, tools and similar equipment you can see in my experiments. So thank you all, you are awesome. Just very shortly, why do you need a filament dryer? All filaments can absorb moisture from the air, which may have a negative effect for your 3D printing. But I don't want to talk about the details. Instead, I wrote an article on my website, so the link is below in the description of the video. You can read it there, because I don't want to repeat everything in every filament dryer review video. So back to S2, it is currently so new product that it is not available for public. I got one exclusive from the early production line. And usually it arrives with some fancy box. This is from the S1, but it arrived only in this packaging because the boxes are still in the production, and even the manual I got only by email in PDF format, but here I can see the electronic version now on the screen. So in the box I got the filament dryer, the power adapter, and the output of this power adapter I can see it is 24 volts, 2 amps. Which give us maximum power of 48 watts, which is actually equal like with the Sunlu S1, which is not really promising, but also in the box I got the bill from the customs to pay some tax and VAT fees. Now here you can see the comparison table about the specifications, so I can see some improvements. And the biggest improvement is that the older version can be heated up to 55 degrees Celsius, the set temperature actually, and the S2 to 70 degrees Celsius. But the S1 never reached that 55 degrees Celsius, I measured that. But probably the reason is that the sensor is somewhere below the heater plate, down. And I believe, I'm not sure yet, but the sensor on S2 is behind this display, but let's take a closer look of the design. Here are two power adapters side by side, so this one is the new version, and maybe it's visible, I hope it's visible on camera. Both works on 48 watts power. As you can see, it has very nice, interesting, futuristic design. It is completely rounded compared to the older version, which is very close to the square. This is not good for heating, because here we have some unused spaces, because here the air also has to be heated up. But since it don't have the fan, even in the newer version I cannot see the fan inside. A lot of users use this space to DIY some hacks and to add a fan and a place for silica gel. It has very big display here on the front side, on the side. I can see only one exit for the filament, and it's here. And we cannot drill anywhere, any other place, because as you can see it has the heater. It has the heater from two sides, from bottom and from the top. There is the display, and I can see some holes here. I believe there are sensors for the temperature and maybe from humidity, so it's much better because it's not down below the heater. It will give more realistic values. And yes, this one has the humidity meter too, because the older version didn't have that. And I can see those wires going down, I believe, to the heater, and also these wires goes up to this heater too. It has those rollers down, so we can place the filament on those rollers. I cannot see insulation on this plastic on the side. On the older version we had that insulation. And on this side this is a display, so I believe it gives some heat anyway. And it stands on these legs. And I'm looking where is the... here is the input for the power cable. Theoretically, the dimensions for the spools are 210 mm in diameter, and 85 mm is the width of the spool. So this means the regular side of the spool can fit inside without any problems. This is a BQ filament, which has a smaller diameter, but the thickness is 76 mm. no problems for that. But I believe this will be a problem. I have some process filaments which have a thickness of 94 millimeters, and no, they cannot fit inside. Well, actually they are on ball bearings, but theoretically they are inside, but they are not sitting completely down on those rollers. They are sitting on the ball bearings, so theoretically 85 millimeter is the maximum thickness. And as you can see, there is no dedicated space for silica gel inside the dryer, but you can always add one inside the spool. Only pay attention to somehow lock the position, because you don't want it to fall out during the rotation and to lie down on the heater. Let's give it a power and turn it on to see this display how it works. It looks like it will be a touch display. Double tap and it's on, and this screen is beautiful, and the PV is the measured temperature and humidity, and if I press the set, it blinks this line, so I can now set, I think, yes, the Celsius or Fahrenheit. I will left it in the Celsius, and if I press the set again, now the SV blinks, and here I can set the temperature. I think the maximum should be 70 degrees Celsius. Yes, and then again set the time. So here you can see the timer. I can set the time. I'm not sure what is the maximum. Looks like it maybe 99 hours. I'm not sure, so I will not change that. And then very interesting, material. So here they have a preset materials: PLA, polycarbonate. This is the nylon, ABS. And here the temperatures are preset for the values. Not 70 for PLA. The LED, well, it's too daylight, but I'm not sure is it visible. Very nice LED, probably in the darker room it looks very nice. And that's it about the settings. Only I will change the PLA. It's not 70 but back to 50, because we can adjust these preset values for the material for our needs. And yes, a very nice and responsive display, so I really like this solution. And that's it about the settings, and double tap and it will turn off. And it looks like it works, and it doesn't make any kind of sound. So probably it has some solid state relay for the turning on off the heater, and unfortunately it doesn't have a fan, so but at least it is quiet. So this is beautiful improvement compared to the older version. Now usually I have that experiment where I put some PETG into water overnight, and then I print something and it will be full of stringing, and then dry it, and after drying it will be clear. But I already did that with the S1, and I know it is able to dry PETG without any problems. It is not able to dry a nylon. I tested that too. But instead I have that new experiment which became my standard with the filament dryers. Everything is explained in that 6 filament dryer comparison video. Basically it is just drying a sponge. I have these sponges for the cleaning soldering tip. I will add exactly 2 milliliters of water, and I will dry it for exactly 1 hour, and I will measure the weight again after that, and then from that I know how many water evaporates. Also I will measure the weight after half hours too. And usually that video was recorded down in the basement, but in that time it was 22 degrees Celsius there. Now it is 17. I don't have heating possibilities there, that's why I record here, where actually the environment is very similar. Now it is here 23 degrees Celsius and 48% relative humidity. I have this plate, and this part is printed from ABS, so the sponges will be on the top of this object, approximately 50 millimeters above the rollers. Here it is a little bit harder to add this sensor. This is the only hole I have, and oh no, it cannot go through the hole. In case you want to use it with the 3mm filaments, in that case you can press in this silicone part, and then you have a bigger hole, which actually I need for these cables. Here it will be much easier to add the sensor. I just place it here and it's done. The first sponge. .688 grams, and now let's add 2 milliliters of water. .720. And the second sponge, 0.680 grams, 2.730 grams. I try to place the sensor in the center where the spool would be, so there is that one, and this one is approximately here below the display. Okay, I set the maximum temperatures 55 degrees Celsius here and 70 degrees Celsius here, and the clock starts. And I cleared the output of the Arduino with 1 or 2 minutes later, but now I'm collecting the data from inside. Half hour passed, now let's measure the sponges and then place them back immediately. 2.413. 2.253. Drying is finished, now let's measure the weight. Drying is finished, I will turn off the power and I will continue collecting the temperature to record some cooling process, but now let's measure the temperature. And I want to show you quickly the moisture on the Sunlu, and well, actually here it is dark, so it's not really visible, but on the older version I can see a lot of moisture because you don't have any space to run out, only maybe through this hole. But here we cannot read the hole because we have the heater there, but let's measure the weight now. 2.093 grams. 1.729 gram. And now I will record the temperature, maybe 15 more minutes to record some cooling speed or something like that. And after that I think I can collect the data and analyze the results. One more thing I want to measure, and that's the temperatures of the heating plates. So here on S2 we have 2 on bottom and the top. And also I want to measure one more time the heater on the S1. And I will glue it with this Kapton tape, the sensor. I will place back this silicone rubber into this hole because I will use it with 1.75mm filament. It is interesting to follow the measured temperature. Now it is 51 degrees Celsius, but it's open, so definitely it doesn't measure the temperature of the air, but the sensor is somewhere, looks like below the heater somewhere. Well, I was waiting 5 minutes and looks like the temperature stabilized, so it is 46 degrees Celsius. This means theoretically I should touch it with my hand. Yes, definitely, it's rare. So 46 degrees Celsius on the upper plate, and let's measure the bottom one. And approximately only after 2 minutes the temperature stabilized 71 degrees Celsius, so approximately 71 degrees Celsius, and that's exactly the set temperature now. (70°C) is the set temperature and the measured temperature, so it looks like unfortunately this sensor is not the temperature of the air, but the temperature of the heating plate. It looks like I found a hot spot because I don't remember that I measured here so high temperatures. 84-85 degrees Celsius on this spot here, and this sounds good, but it's not really because the heating of the filament is not equal, so from the bottom it gets a really lot of heat, which may even then form sometimes some spools. So this is the result of that sponge test, and here you can see the weight of the removed water in grams or in percentage, and also that percentage is presented on this graph. So we can see that S2, the newer filament dryer, has better drying capabilities compared to the S1, even if they have the equal power of 48 watts. And it will perform even better on this test if I would add a silicone gel inside, or if it would have some kind of fan or somehow removing the moisture. And now let's see the temperatures and relative humidity. So these two graphs lines are for the relative humidity, and these two are temperatures. And here you can see that I opened here for 30 minutes measuring, and here you can see the biggest problem of this filament dryer is that the moisture, the humidity is stuck inside. And when I open it to take out the sponge to measure the weight, I let out the humidity. And then here it was stopped after 1 hour, and actually here we can see this cooling time. So the temperature, we can see that the S2 reached approximately 50 degrees Celsius until the S1 was a little bit above 40 degrees Celsius. And we have measuring the temperatures and the moisture on the filament dryer. So the measuring the humidity was accurate. On dryer I can see on that time lapse it was around 54-53%, and it's very similar to measured by this DHT22 sensor. But the temperature, unfortunately, it looks like this is the temperature of the heater and not of the air, because on the display I saw that after 5 minutes it shows 70 degrees Celsius here, but the temperature of the air was below 40, for example. Here this is definitely not good, because it would be better if we could really reach the 70 degrees Celsius of the air. In that case I would say it could be capable to dry even nylon too. And now the conclusions, but first I want to mention one error I noticed in my experiments. And it is good that I did a comparison video again, because the Sunlu S1 in that 6 filament dry comparison video reached approximately 42 degrees Celsius, and in room temperature was 22. Now the room temperature is 23 degrees Celsius, but it reached only a little bit above 40 degrees Celsius. And the reason is that in that experiment I placed 6 filament dryers next to each other, so the Sunlu had a filament dryer from each side, and probably that helped a little bit to get a little bit higher temperatures. I apologize about that mistake, which I noticed only now, but that's what is good, that I did a comparison video compared with S1 and S2, and the improvement is obvious. I was worried a little bit because I saw that the power is equal, but even if the newer version don't have so high temperatures on the heating plate, but it's good because the heating is equal and the volume is smaller, so it heats up the air much faster. And I really like this touch display and also the preset values. So I can just choose the PLA or I don't know, PETG, and it has already preset values, temperature and the drying time for those materials. But of course you can change this. And this one also you can change the degrees Celsius or Fahrenheit. I think here I didn't notice that I can change to Fahrenheit, only degrees Celsius. What I didn't like with this filament dryer, well, the temperature. It looks like the measured temperature is the temperature of the heating plate, not of the air inside. Because for drying a nylon, just to clear something, both are good to dry a PETG completely. I had that experiments earlier, but they are not strong enough to dry a nylon, because the drying process has two phases. One, you need higher temperature to force the moisture from the filament to the surface, and then you need a drier environment to that moisture evaporates from the filament. But here 50 degrees Celsius is not enough to dry a nylon completely. But it is good enough to keep it dry. For example, if you dry it in the oven on, I don't know, 80 degrees Celsius, and then you can use this filament during 3D printing, because you cannot print from the oven. And in that case, this is very useful tool, even with the nylon, to keep it dry during the printing process. I don't know, I think I covered everything. Maybe it would be good to have a little bit more axis for filament, not only this one, because we cannot just drill it anywhere, because we have a heating plate on the top, maybe from the side. And maybe it would be useful to have some insulation on this surface here. I would like to see a little bit wider dryer, so my Prusa filaments with this on this wider spool can fit inside. As I mentioned, this is I think for the 94 millimeters. And I don't know, I'm still missing a fan inside, but a quiet fan. So please, if S3 will have a fan inside, use some quiet fan, because it is extremely good that they don't produce any kind of noise. That's very positive thing, but there is no dedicated space for silica gel, but of course you can add the silica gel inside the spool, only pay attention that it will not fall down during the rotation. And I think I try to cover each element. If I skip something, then write me in a comment, maybe I will add it in the description of the video. Thank you for watching and happy drying and printing. Bye.